Welcome back to it. It's your favorite and your awesome tutor. I'll be doing hyperbolic function today. On our last video, what we did parabola and linear function. Today we try to do hyperbolic and exponential function. Hyperbolic is one of the simplest functions that we'll ever get. You just need to understand. I promise you, in the next 20 minutes, you'll be understanding hyperbolic functions. Right, in the next 20 minutes you'll be understanding how to apply hyperbolic functions and how to get the hyperbolic equations and the asymptotes and the the x-intercepts and the y-intercepts. Okay, now let's get to it. This is we will be doing the basic today. Part of the basics is the formula of a hyperbola. Part of the basic is the formula for hyperbola. Now, the formula for hyperbolics, it is this one: y is equal to a over x minus p plus q, where p and q represents the asymptotes of the hyperbolic function. They represent the asymptotes of the function. The asymptote, it is what you call the two lines that our graph will never touch. They will go, the graph will approach the two asymptotes, but it will never touch it in any ways, right? It will move closer and closer and closer to it. It will never touch it. And then we have this is the shape of our graph. This is the shape of our graph, right? This is the original graph of the hyperbolic or of a hyperbola, right? Where in this case, this and this are zero, meaning your equation is something like this, right? Meaning your equation is something like this. Your p is equal to 0 and your q is equal to 0, right? These are the asymptotes of the graph, right? Now, what is the value? Why is our graph in the first and the third quadrant? Why is our graph in the first and the third quadrant? That is a very important question. Simply because a is greater than 0. When a is greater than 0, or when a is positive, our graph will lie between the first and the third quadrant, right? That is the rule for the hyperbola or hyperbolic function. Now, what if I'm to say this is my graph, this is where my graph lies, this is my graph, right? That is my graph. What can I say, or what can I conclude about this graph? I can simply conclude that a in this case is less than 0, or a is negative, right? When a is negative, my graph will lie in the second and fourth quadrant. My graph will lie in the second and fourth quadrant when the value of a is less than 0, or when the value of a is negative. Now, p in this case will represent my vertical asymptote. This represents my vertical asymptote, right? Meaning represents this line. That is p, right? Then q represents my horizontal asymptote. Right? Now, when they say, sometimes they'll just say, write the equations for the line or the asymptotes. Write the equation for asymptote, okay? When they say I must write the equation for the asymptote, I'll write it and say x is equal to p, right? And y is equal to q. Those are my equations, right? Those are my equations, right? Okay, now let's move to the next thingy that we need to talk about. We also need to talk about this, guys. We need to talk about this, guys. They are very important. They are called the line of symmetry for our graph. They are called the line of symmetry for our graph. And the equation for the line of symmetry, we have a positive equation and a negative equation. Or sometimes they call it a negative gradient or a decreasing gradient. Sometimes they call it a positive gradient or an increasing gradient, right? So you can just write it like this and say, sorry about that, I live in a very loud place. I'm very sorry. Okay, now we are talking about a symmetry or line of symmetry, symmetrical lines. Symmetrical lines. We have a positive line of symmetry. Line of symmetry, right? And it is represented, or it is also called an increasing line of symmetry, or a positive gradient line of symmetry. Line of symmetry. Let me not be lazy. Let me just write it. Line of symmetry. Right? Now, how do we write a positive one? A positive one will always be like this. Y is equals to x plus c1. Right? This is the positive one. Remember, when you come to that thing that is called y is mx plus c. So, as you can see now, here we have 1, but we don't write it. So this represents my my gradient, and as you can see, we don't have a negative sign there. It is positive, right? It represents my gradient. Now, what do we substitute here to get? What do we substitute here to get our line of symmetry? What do we substitute? We always substitute your minus p is to q. What is your minus p is to q? We always substitute the asymptotes, right? Asymptotes. Never substitute any other coordinates. Never substitute any other coordinates. In the sense, in this question, they will never ask you to determine the line of symmetry if you haven't determined the what you call the asymptotes. They'll first ask you to determine the asymptotes. After that, they'll tell you you should write this. You should write this. This is your formula, right? This is your formula. Your gradient, in this case, in most cases, it will always be 1, right? Your gradient in most cases will always be 1. So you just need to substitute your x and your y to calculate the value of c, then rewrite it. Y is equal to x plus the value that you got, right? Okay, now, let's continue. We have a negative 1. We have a negative line of symmetry. Sometimes, or symmetrical line sometimes is called a decreasing line or function, right? Line or function, right? Sometimes called a negative gradient line, right? So if they say one of the 3 sentences, never be confused. If they say one of the 3 sentences, don't be confused. You must just know that they are talking about the line of symmetry. And this one is written like this. It's y minus x plus c1. You see, if you can check, they are different. This one is positive, this one is negative. These are the line of symmetry. I hope you understand. Let's move. Okay, don't forget to subscribe. Okay, let's continue. Let me say I'm given a graph like this. This is the original graph. Right? This is the original graph. Then they talk about this, friends. The domain and the range. Domain and the range. Okay, what is the domain? What is the range? I did explain this thing on my previous basic of parabola and linear. I did define it. If you don't know it, please go to it. Go to the previous video. You will see and get more in more detail what is a domain and what is a range. Right? In this case, my range and my domain, it is the x, the element of real numbers. Right? This will always be 2 marks and greater, right? This it'll be 2 marks or more than 2, right? Now, x is the element of real numbers. Am I done? No, I'm not. Why? I have conditions. If I say x is the element of real numbers and leave it like that, what I'm trying to say, or what I'm giving you, it's wrong, because I'm saying my graph lies throughout this thing, or else we have conditions. Yes, this is correct, but this alone, it's not, it's incomplete statement, right? This alone is incomplete statement, and it will never give you 2 marks, right? Or 3 sometimes. It will never give you 2 or 3 marks. What is domain? Is the element of real numbers, but my x can never touch this. My x can never touch this. Now, this qualifies me for 2 marks. Now, that qualifies me for 2 marks. Because what I said, my graph will never touch the asymptote. Asymptote, it is the line that my graph will never touch. Right? Very important. Very, very important. Okay, now let's go to, let me just check a different color. Let's go to a range. What is a range? Range is also what you call, why is the element of real numbers? But this alone will never give you 2 marks. That alone will never give you 2 marks. Now, another thing, a learner can just say, can't I write this thing in a different way? Can't I write it in a different way? Okay, let's just complete this one and then I'll explain another way of writing this. Why is the element of real numbers? Again, y can never touch q, right? This is my second asymptote. Y can never be equals to q, right? Y can never be equals to q. But you can also write this thing in a very simple manner and say, oh, my graph is going this way. If you can check my x values, right? It's going this way. So I can just say, oh, my graph will start at negative infinity up to which point? Up to somewhere closer to that, right? Up to somewhere closer to that, which is my p, right? Up to p, right? So is this thing correct? Yes. Is this thing, let me just try to write it in a different manner. Is this thing correct? No, this is wrong. Why is it wrong? This is very wrong. Extremely wrong. Never write that. Why? If I say this, I'm saying my graph touches that. If I say this bracket, it tells me that my graph touches P, of which it's not correct. Of which it's not correct, right? It's not correct. My graph will never touch P. That is why I use those brackets, right? That is why I use those brackets. Okay, that is why I use those brackets. Am I done? No, I'm not. I'm not done. I'm not done. U and, okay, into, oh, my graph will again start at P up to positive infinity. Up to positive infinity. Don't write this thing, this bracket to look cool. Don't write this bracket to look cool to your teacher. It's not gonna be right. It's gonna be wrong, right? Don't say, I know these things, man. I know this. I can just use a square bracket. It has a meaning, and this, it has a meaning, right? So this is very wrong. This is very wrong, but this, you get your 2 marks. You get your full 2 marks, right? Now, let's go to this one. Can I write this one in that form again? Yes, I can. Yes, I can. Why? Because my graph is going from this point, it's moving from this point, from negative, it's from negative infinity up to q, right? Right? From q up to positive infinity. There's my statement, right? This makes total sense. This is correct, right? Please don't use the square brackets if you don't understand how to use them. You rather use this method if you don't understand the square bracket method. You rather use x is the element of real numbers, x can never be p. Y is the element of real numbers, y can never be q. Because you know your graph will never touch these points, right? Let's move to the next one. Okay, we are done with the basics of what you call hyperbolic functions. We are done with, as far as the basics of hyperbolic functions, we are done. And then I'll make sure that I'll do questions so that everyone is comfortable. I'll do as many questions as I can. If you have a question as well, just share it, and then we'll try to figure out the solution together. Now let's move to exponential functions. We're also doing basics. We need to know the basics, and after this we will be doing questions, and so many questions, because functions, it has so many marks. You need to score at least 60 to 70% from functions if you don't get 100%. Now let's move. From the basics, we have our basic formula. From the basics, we have our basic formula that says y is equals to abx plus q. Okay, minus p plus q. Right? Now, what is p? What is q? What is p? What is q from my graph? Okay, I know q is my asymptote. Q is my asymptote. Now, in this case, we only have one asymptote, which is q, right? Which is q. And if I have my set of axes like that, and then the original graph will just move like this. This is the original graph. It will never touch this point. It will never touch this line, right? It will never touch that line. So that is the first condition. Now, we also need to talk about, why is my graph like this? Why is my graph like that? Why is it not like that? Why is it not like this? Right? Why is my graph not like that? Now, that is controlled by the value of b. That is controlled by the value of b. Now, if the value of b is greater than 0, how will my graph be? If the value of b is less than 0, how will my graph be? This is my graph where, okay, actually it should be b is greater than 1, because we talk about this point here, where original graph we always have this point as our 0 is to 1, right? Even if you are not given that point, but you must know that it is the case. Even here you have your 0 is to 1. 0 is to 1. Always. That is the case, right? So even if you are not given the coordinates, you must be able to conclude and say, oh, this thing, I know it. But Leonard showed me how to do this, right? Leonard showed me how to do this, and I can just apply it and then get whatever I'm required to get, right? If my b is greater than 1, that is the case. If my b is less than 1, that is the case, right? Oh, these are positive when b is greater than 1, b is greater than 1, b is greater than 1, right? Or when b is in between 0 and 1. That is the case. When b is in between 0 and 1, this is the case, right? Now, when this is when b is positive, right? This is when b is positive. Then we also have this, something like, how can I draw it? Oh, something like this, right? And again, we also have something like, how can I draw it? Something like that, right? This is the case where now the value of b is less than 1. When the value of b is less than 1, this is the case, right? Or you can just say when the value of b is in between 0 and 1 again, right? That is the case. That is the case. Okay, now let's move. The exponential function, it doesn't have so many things. As far as the exponential function, we are almost done. We are left with what we call the domain and the range. The domain and the range, right? So domain, when I have my graph like this, in most cases my domain of this graph will always be x is the element of real numbers. In most cases, right? it will always be like this. Why? Because my graph lies in between the x positive and the x negative. It lies in between the two. This is the statement that proves that my graph lies in between the two, right? And then, what is my range? What is my range? I have a graph like this. They say determine a range. What is my range in this case? My range depends on the asymptote, right? My range will always be greater than the asymptote, greater than q, right? In most cases, that is the case, right? Where it is, or you can write it and say q greater or equal to that. That is my range, right? For a positive graph. For a positive graph. For a negative graph, you can say this is for a positive graph. For a graph like this, can I draw it like this? Graph like that. For a graph like that, so from negative infinity up to q, right? From negative infinity up to q, that is my range, right? For a graph like that. As far as the functions we are done, please don't forget to like, share, comment, because we need those comments. And if you have a question, share it with me. I'm gonna leave my contact details so that you can just share it directly to me, and then I can assist you with it. Please enjoy, and good luck with your exams. I know you can do it. I believe you can do it. I know you're going to kill them, as long as you are always checking out these videos